Since the agri-food sector relies heavily on the production of agricultural products, we're going to begin the course by developing an understanding of the technical aspects of production. At a basic level, this is about how firms take inputs under their control, transform them into outputs, and then supply the market. We begin by analyzing the production processes or physical relationships between inputs and outputs. All production choices are conditioned on the underlying physical properties of the production process. There are certain physical input-output transformations that can't be altered in a given production framework and decision environment. We're going to focus exclusively on this technical aspect of production, on the physical relationship between inputs and outputs. And then later we're going to incorporate prices to understand how economics can govern the production choices that are made by a firm or a farm or someone who has an economic activity that they're trying to undertake. Now, when we deal with production, we're also dealing with the relationship, or trying to capture the relationship between inputs and outputs. That's actually surprisingly a difficult thing to do. Economists have spent a lot of time using things called production functions to try to capture that relationship. And all a production function is the technical relationship between the inputs and the outputs. It shows us the maximum amount of output that we can get given that we've applied a certain number of units of variable inputs and given a particular state of technology. If we change the amount of inputs that we use, that's going to change the amount of output that we're going to get. If we change the technology, that's also going to change the amount of output that we're going to get. But I want you to remember that these production functions simply characterizes the physical relationship between the input used and the output level that's achieved by applying those inputs. It's actually really quite simple. It's just a rule. It shows how much output you're going to get given the amount of inputs that you've used. And it's also based on a given state of knowledge. If that knowledge changes, so for instance, if someone in plant science or in animal science comes up with a better production technology or a better way of producing outputs, then these production functions will also change. That actually has some important economic consequences that we're going to talk about throughout the course. Now, because we're trying to capture the relationship between outputs and the inputs, we need to think about different ways we can get that across. And one of the things you're going to learn in this course is that when we talk about economics, and even the technical aspects of production in the context of economics, we can do it with different ways. With respect to production functions, one way we can do this is capture these relationships through tables. We can also capture them through graphs, and we can capture them mathematically. This is an example of a table that shows the production function relationship between the units of nitrogen that have been applied to an acre of land and the corn yield that came about from that application of the variable input nitrogen. And what we see is that when we have no nitrogen applied, we get 48 units of corn. When we go to 40 pounds of nitrogen per acre, output goes up, and so on and so forth. Now the table is useful. It provides information. It provides data. We can do things with that, but it's not a very visually or intuitively appealing way of capturing this relationship. So what we sometimes do is actually plot these relationships. And what we've done here is on the x-axis we've plotted the amount of nitrogen that's been applied, and on the y-axis the amount of corn yield that we've gotten for the given level of nitrogen application. And all this shows is that as we increase the amount of nitrogen that's being applied to this plot of land, that's increasing the yield of corn. That does reach a maximum at some point and then begins to start to decline. And what we're really doing there is saying that at some point application of more nitrogen isn't necessarily better because the nitrogen is then burning the resulting corn. So these are examples of how we can capture these production functions both in a table form and also in a graph. We can also capture the production function through a mathematical relationship. Now, there's not a heavy math component in this course. You need to be able to do some math, but we're not asking you to do some difficult differential calculus or anything like that. But it's important to remember that these production functions can be captured mathematically, and we can actually go out and get data and use statistical analysis to measure the relationship between inputs and outputs. If we want to choose to capture a production function mathematically, we could write it as y, where y is some quantity of output of a good or a service, as a function of x and z, where x and z are inputs, different inputs that are used in the production process. And that function f is simply the form of the relationship that captures how those inputs get turned into outputs through the production process. we can actually apply this type of analysis to the data that we just showed on the previous slide, and we can look at a linear equation for the corn nitrogen example, where if we use statistical analysis, we could find that corn yields in a linear model increase positively as you apply the amount of nitrogen. Now remember back to that graph where we showed that there was actually a point where yield goes down as you start applying more nitrogen. That would suggest that maybe a linear relationship doesn't make sense, but a nonlinear relationship makes sense. We might estimate it using a quadratic equation. That's the bottom line that's shown on there, and all that does is say that the relationship between yield and nitrogen application is actually more complex than a linear relationship. Now, one thing that I've said at the start of the lecture was that it's the relationship between inputs and outputs is really about how you vary inputs. And so what I'm getting at there is that there's some inputs in a production process that are fixed, they can't be changed, and there's some inputs that can be changed, they're variable. And so this gets at this notion of different types of inputs. And when we're dealing with different types of inputs, we need to think about what are called the factors of production. And the factors of production are basically all the inputs that get put together to create an output. The goods in an economy can be classified into two categories. They can be classified into a consumption good. This is really the outputs that contribute directly to an individual's utility or well-being. So these are the things that we consume. Food that we can buy in the grocery store and consume, a cup of coffee that we might buy, an automobile that we might buy to use for our own personal use. Those are all consumptive goods. Factors of production are the inputs that are combined to create those outputs. And the role of the firm, or the farm in the case of this course, is to convert those inputs into outputs. Now, there are different categories of inputs that get used. We can distill this down into four broad categories. The first one is land, and this includes not only the land itself, but also other renewable resources that might be associated with that land, such as minerals, forests, and groundwater. We can also think about labor as a factor of production. In fact, labor is a very important factor of production in all sorts of different economic activities. This includes all labor service used in production, with the exception of managerial activities. We tend to separate labor from management, partly because people who are in a managerial role have the responsibility of making decisions, while people who are in a labor role don't necessarily make the decision, but they implement the fact that someone's made a decision and told you to go out and do something. It's kind of like when dad kicks you out, gets you up out of bed and tells you to go and milk the cows. Dad's the manager, you're the labor. Capital is another input that we might also think about, and this refers to different types of manufactured goods that are going to be used in the production process, such as fuel, chemicals, trucks, buildings, those types of things. It's not just stockholder equity, it's actually physical things that we can actually look at, so tractors, farm implements, chemicals that we're going to use. And these are important because they aid in the production of goods and services. Another category of input that we need to talk about, and I mentioned briefly, was management. And this is about people who make decisions on how, when, and what to produce, how large to grow, and how to finance the expansion of an operation. Now, I've got the word management in here separate from manager because management is a task. It's the decision-making process where those few resources that a firm has are allocated to different production alternatives in a way that's going to attain some sort of an objective. So typically in economics, we assume that the decision-making process is one where firms choose the level of inputs to maximize profit, because firms in our society are in a capitalistic society, and their aim is typically to earn as much money as possible. Now, so we've got these four categories of inputs. We can actually divide these up in a little more meaningful way when we start recognizing that when we're making production decisions, some of these inputs are fixed at a given point in time. That is, you don't change them and you can't change them, while others you can change. This gets at the notion of fixed versus variable factors. And a fixed input or a fixed factor of production is one that the firm can't change the quantity of regardless of the level of output. So in a given crop year, when you plant your land to corn or soybeans or spelt or whatever it is you're growing, the amount of land that you have once that crop is in the ground is fixed. You can't necessarily change that. Now you could argue with me about whether or not, okay, well I could go out and rent land. That's true, but once that land is in that seed, once you've planted, it's a fixed factor of production. You can't change that. Now that's opposed to variable inputs, which can be altered according to the amount of output that you want. So as opposed to land, which is a fixed factor of production in a given crop year, we could think of agricultural chemicals as a variable input because you can actually alter the amount of those agricultural chemicals that you apply, and that will change the amount of output that you grow in the subsequent year. And this last bullet point is really just sort of emphasizing what I've just talked about, that for a farmer, land will be a fixed input and seed, fertilizer, hired laborers are variable inputs in a given crop year. I recognize that between crop years, that land will become a variable input in the sense of you can go out and buy more land or you can rent more land. Now, we also think about these fixed and variable factors of production with respect to time. And we talk about the time and the variability of inputs. And here what we're making a distinction between is periods where we have some fixed factors of production or some fixed inputs, and when all inputs can be varied. When we have at least one factor of production that can't be varied, if we have one fixed input, then we're dealing with what economists call a short run. And all this gets across is that you can't change that one input, and so the other production decisions are actually going to be governed by being made in a short run decision. We don't think about this in terms of lengths of weeks, months, or years. We think about it in terms of whether or not a fixed factor of production exists or not. In the long run, this is a long enough period where all inputs can be varied. So over the course of 5, 10, 20 years, we could think of those production decisions being made in a long-run environment as opposed to a short-run environment. And again, I want to emphasize there's no specific length of time that constitutes the short and the long run. This has to do with, and only has to do with, whether or not a particular input is fixed or not. For now, we're going to assume that we're in a short-run production period, and so this means that at least one input is fixed. In fact, we're going to make our life a little bit easier, and we're going to assume that all inputs except for one is fixed. In the example that we've been talking about, that input was the variable input nitrogen. I'm going to change gears and actually use labor to talk about that as a variable input, partly because that's what the textbook does, and I want to make sure there's at least some alignment between what you're seeing here on the videos and in the notes and also in the textbook. So when we talk about production relationships where we have one variable input, we think about something called total physical product. And in fact, we can think about total physical product when we've got all inputs that are being varied. And all the total physical product, or TPP, is the quantity of an output that a firm produces in a given amount of time. It's just some measure of output. Economists talk about total physical product curves. In the textbook, I think they call this total factor product or total production. This shows the relationship between output and one of the variable inputs, and it's also called the firm's short-run production function. This is an example of a total physical product curve. It shows on the x-axis the number of workers that a firm has been using, so this might be someone who's hired workers to pick grapes, for instance, in a winery, and the amount of output that those workers have generated through their activities. Now, total physical product is useful because it shows that relationship between outputs and inputs, but it's not the only thing that we use as economists. We actually start thinking a little more carefully about total physical product in relationship to the amount of outputs that are being used. One way we do this is through this concept of average physical product, or APP. An average physical product is simply a measure for a given input, given variable input, and it's the total physical product divided by the number of units of that variable input that have been used. So it's really just output divided by input. So examples of this might be milk production per cow, so kilograms or liters of milk per cow, or maybe kilograms of butterfat per cow, or kilograms or bushels or tons of corn per hectare of land. Now we can figure out APP from the TPP curve. Now this gets a little bit complicated, so I'm going to go maybe a little bit slower than you might like, but I think it's important that we do that. APP can actually be measured based on the total physical product curve. And we do that by simply measuring the slope of a line through the origin of the TPP curve to a point on the TPP curve. So for instance, if I drew a line from the origin to the point where I had 2 units of labor, the slope of that line tells me average physical product for 2 units of labor. And remember, slope is just rise over run, and so the rise in this case is output, and the run in this case is the units of input. If I wanted to figure out average physical product when I've applied 4 units of labor, I would draw a different line from the origin to the point on the TPP curve that corresponds to where I used 4 units of labor, and the slope of that line would tell me average physical product. And so I can do that for different input levels, and what you would see is that slope of that line gets steeper and steeper and steeper. It'll reach a maximum steepness, and then as I start drawing it for higher and higher levels of input use, what's going to happen is that average physical product is going to fall. That is, the slope of that line from the origin to the point on the TPP curve is going to become shallower. So if I actually plot APP against the number of units of labor that I've used, what I'm going to end up with is a curve that looks like this, where each one of those dots on the curve represents the average physical product corresponding to the number of units of labor that I've used to produce that amount of output. We're going to go through an example of this in class, so don't worry if that doesn't seem entirely intuitively clear. I want to use the classroom to try to make sure that we capture some of the nuancing on these issues. Another measure that we use to capture the relationship between inputs and outputs is marginal physical product, or MPP. And marginal physical product is simply the addition to total physical product from an additional unit of the variable input, where all other inputs are fixed. So this is really about the change in output that comes about from a change in inputs, a small change, in fact, a 1 unit change in the variable input. So we can capture MPP as the change in output arising from some change in input. If you're familiar with differential calculus, this is simply the derivative of TPP with respect to the variable input that you're concerned with. Now, MPP also has a relationship to the TPP curve in that marginal physical product is simply the slope of the TPP curve. And to illustrate that, we can go back to our total physical product curve and start plotting the slope of that curve at different points. So if I had 2 units of labor, that black line I just drew shows me the marginal physical product for 2 units of labor. As I add more units of labor, I can actually then calculate the marginal physical product as the slope of the TPP curve at that point. And this is just simply trying to get at how a change in input changes the level of output. And we can do that for different levels of input as I'm doing here. And what you should see is that marginal physical product starts out rather shallow, gets steeper and steeper and steeper, hits an inflection point, and then starts to become shallower and shallower and shallower until one point, that is at the peak of the TPP curve, marginal physical product is 0, and as we go past the peak of that total physical product curve, MPP falls to a negative number. That is, we get a negative slope. So as we add more units of input, that actually reduces the amount of output that we're going to get. So again, just to reiterate, the slope of that TPP curve at a given level of input is marginal physical product. And we can plot the marginal physical product levels across the different levels of input use as I've done here. And what you should see is that the marginal physical product equals 0 at a point that roughly corresponds to 11 units of labor. Well, if we go back to the slide earlier, that's where we saw the peak of total physical product curve. We know that at that peak, that's where the slope of the line is going to be equal to 0, and so we know that marginal physical product at that point is going to be 0. One last thing that I want to talk about is actually an important notion that's tied to marginal physical product, and that in fact is very important to any kind of production environment. So even if you don't want to get into agricultural economics or agricultural business, what we're going to talk about next is really important because it governs all sorts of things that we see when we're dealing with production. So if you want to grow Christmas trees, if you want to grow grapes, if you want to raise beef, if you want to raise crops, this principle still applies. Doesn't matter what you're growing, it applies. And this is the notion of the law of diminishing marginal returns. And in fact, this is tied to the marginal physical product curve because the shape of the marginal physical product curve really reflects this notion of diminishing marginal returns. And the law of diminishing marginal returns simply says, as increasing amounts of one input are added to a production process while all other inputs are fixed, after a point, each additional or incremental unit of that variable input produces less and less additional output. And so if you think back to what the marginal physical product curve looks like, as we applied more workers, the marginal physical product rose, it reached a peak, and then it began to decline. Well, that's where we're beginning to see diminishing marginal returns is as in the region of the marginal physical product curve where its slope has become negative. As we apply more inputs, we're getting smaller and smaller increases in output, and at some point, in fact, we're going to get negative marginal returns where we actually see reductions in output as we apply more inputs. Now, to call this returns is a bit of a misnomer because we haven't said anything about prices, revenue, or cost yet, so we can't even think about physical returns. So this is really about diminishing marginal product, if you want to call it that. I'm happy with you calling it diminishing marginal product or diminishing marginal returns. Just make sure that you get across that notion that it's the region where that marginal physical product curve is actually falling. This is a good place to end today's video. We'll go over the concepts that we've talked about in class briefly on Wednesday, and then talk about some examples of how to calculate APP and MPP.